Imagine transforming your 3D prints from ordinary to extraordinary with just a few tweaks. It sounds like a dream, doesn't it? But what if I told you that it's not just a dream, but a reality you can achieve with the right slicer settings? That's right. The difference between a good print and a great one often boils down to the slicer settings you use. Now, we're not talking about a magic bullet here, but a series of carefully chosen settings that, when combined, can dramatically improve the quality of your prints. Throughout this video, we'll be revealing these settings one by one, in ascending order of their impact on print quality. From layer height to cooling settings, we'll delve into the nitty-gritty of each one, providing you with the knowledge you need to take your 3D printing to the next level. So, are you ready to elevate your 3D printing game? Stick around, and don't forget to like and subscribe for more tutorials. Kicking things off with the first setting, layer height. Now, layer height is a big deal in 3D printing. Why, you ask? Well, it's because it directly influences two crucial things: the appearance of your print and the duration of your printing process. Think of layer height as the resolution of your print. A lower layer height will result in a smoother print, giving you that much desired professional finish. But there's a catch. Lowering your layer height increases your print time. It's a trade-off, really. You get smoother prints, but you'll have to wait a bit longer for them. On the flip side, a higher layer height speeds up your printing process. But, and it's a big but, it compromises the smoothness of your print. You'll see more of those telltale 3D print lines. Remember, the right balance in layer height is key to smoother, better-looking prints. Next up, the shell thickness. Now, you might be wondering what exactly shell thickness is. Well, imagine peeling an orange. The peel is like the shell of your 3D print. It's the outer layer that gives your print its shape and finish. Just like the thickness of an orange peel determines how squishy or firm the fruit is, the shell thickness of your print plays a crucial role in its strength and finish. A thicker shell means a stronger print, but it also means a longer print time and more material used. On the other hand, a thinner shell can save you time and filament, but it might leave your print more susceptible to damage. It's all about finding that sweet spot, and remember, different prints may require different shell thicknesses. So, for prints that not only look good but are also sturdy, shell thickness is your best friend. Moving swiftly on, we arrive at print speed. Now, you might think that faster is better. After all, who doesn't want their masterpiece ready in record time? However, in the world of 3D printing, speed isn't always your friend. Let's break this down. When you increase the print speed, your printer has less time to accurately place each layer of filament. This can lead to a loss in detail and a not-so-smooth finish. On the other hand, a slower print speed allows for more precision, ultimately resulting in a higher quality print. Now, we aren't saying you need to set your printer to a snail's pace. It's all about finding that sweet spot between speed and quality. You might have to experiment a bit, but once you find it, you'll be on your way to producing smoother, better-looking prints. Remember, in 3D printing, slow and steady might just win you the race. Now, let's delve into the heart of your print with infill density. Infill density, simply put, is the percentage of space filled inside your 3D print. Think of it as the skeleton of your print, providing structural support. A higher infill density means a sturdier but heavier print and more material used. On the other hand, a lower infill density results in a lighter, less sturdy print, but with a quicker printing time and less material used. Imagine building a skyscraper. A solid concrete structure would be incredibly strong but would take forever to build and cost a fortune. Conversely, a structure with hollow spaces would be cheaper and quicker to build, but might not survive a strong gust of wind. Infill density is essentially about finding that sweet spot between strength, weight, and printing time for your specific project. So don't be afraid to experiment and find what works best for you. In the world of 3D printing, it's what's inside that counts. Scene script. Are you ready for some support? Let's talk support settings. When you're embarking on an intricate 3D printing project, support settings become your best friend. They're kind of like scaffolding for a building under construction, lending a helping hand to your design as it takes shape layer by layer. Imagine you're printing a majestic dragon in mid-flight. Those wings are going to need some support or they'll just droop and fall, right? That's where your support settings come in. They help build temporary structures that hold up parts of your design that would otherwise defy gravity. There's a bit of an art to getting these settings just right. Too little support, and your print may collapse under its own ambition. Too much, and you'll have a tough time removing the support structures without damaging the print. Don't let the complexity deter you though. Fiddling with these settings is all part of the 3D printing adventure. With the right support, even the most intricate designs are possible. Things are heating up as we move to temperature settings. The temperature of your 3D printer's nozzle can make or break your print. Why is that, you ask? Well, different materials have different melting points, and finding the right temperature for each is crucial. Picture this, you're baking a cake, too hot and the cake burns, too cool and it's doughy. Same with 3D printing. If your temperature's too high, the filament might ooze out of the nozzle, causing stringing and blobs. Too low, and the filament might not bond properly, leading to weak prints. PLA, for example, likes a cozy temperature range of about 180 to 220 degrees Celsius, while ABS prefers a hotter 220 to 250 degrees. So, don't just crank up the heat and hope for the best. Each material has its sweet spot, and finding it is the key to smoother, better-looking prints. Remember, in 3D printing, keeping your cool matters. Now let's retract a bit and focus on retraction settings. Retraction settings, my friends, are like the unsung heroes of 3D printing. They might seem insignificant, but in reality, they play a pivotal role in making your prints look neat and professional. So, what are these settings all about? Well, they essentially control the pulling back of the filament during the printing process. This retraction prevents the filament from oozing out and causing stringing or cobweb-like structures on your print. Imagine your 3D printer is like a sophisticated pastry chef, and the retraction settings are the precision that stops the icing from dripping when the chef moves to a new area on the cake. Adjusting retraction settings is a balancing act. Set them too high and you might face under-extrusion. Set them too low, and hello, stringing. So take your time and find that sweet spot. Remember, to avoid a hairy situation, retraction settings are key. Closing in on the finish line, let's look at top-bottom thickness. This setting is a bit like the icing on the cake when it comes to 3D prints. It determines the thickness of the top and bottom layers of your object. Now, why is this important, you ask? Well, the thicker these layers are, the more durable your print will be. It's like adding a sturdy roof and solid foundation to your 3D printed masterpiece. However, there's a catch. If you make these layers too thick, you might end up with a print that looks chunky and less detailed. It's all about finding that sweet spot. And remember, this setting can vary depending on the material you're using and the purpose of your print. So don't be afraid to experiment and find the right balance for your project. After all, a smooth top and bottom make for a top-notch print. Last but definitely not least, we have flow rate and cooling settings. Now, why are these so important, you ask? Well, you can think of the flow rate as the maestro of your 3D printing orchestra. It dictates how much filament is extruded during the printing process. Too little, and your print may come out looking like a Swiss cheese. Too much, and you might end up with a blob resembling a modern art masterpiece. Moving on to cooling settings, these are the unsung heroes of the 3D printing world. They control how fast your print cools down, which in turn affects how your layers bond together. Just like Goldilocks, you want your cooling settings to be just right. Too hot, and your layers might warp. Too cool, and they might not bond properly. There you have it, folks. With the right flow and cool, you're all set to create 3D prints that are a cut above the rest. Let's take a breath and recap what we've learned today. We've journeyed through 10 slicer settings that can drastically improve your 3D printing results. Starting with the layer height, remember, less is more for smoother prints. Then we moved on to shell thickness, where a thicker shell equals greater strength. We talked about print speed, and how slowing down can give your prints a better finish. Infill density was next, with the balance between strength and material usage. We dove into support settings, where the right balance can make or break your complex prints. Temperature settings, a game of hot and cold to get the perfect print. Retraction settings came next, a key to prevent stringing. The top and bottom thickness, the gatekeepers of your print's exterior finish. And finally, we delved into flow rate and cooling settings, the dynamic duo for precision and detail. So, buckle up, tweak those settings, and watch your 3D prints transform. Happy printing!